And topic of the day is structure. A structure of the atmosphere. Structure of the atmosphere. On the basis of lapse rate, there could be several divisions. So most popular one is based on the lapse rate. Then another is on the basis of Earth's rotation, gravity, etc. Now coming to the first one. Right, coming to the second one, because second one is easier. Much easy to learn, and the second one is not so popular, but however it is used in meteorological sciences, and the way UPSC has started asking questions, so there is a possibility that this also might be asked. This is 600 meters, or sometime it is taken as 1 kilometer. This is called planetary boundary layer. This is your sea level, or 0 kilometer. So first layer is the planetary boundary layer, or you can call it PBL. Please write. PBL is the imaginary line. PBL is the imaginary line. Above which the terrestrial friction is negligible. Terrestrial friction is negligible. This is called planetary boundary layer, PBL. Now, so friction, terrestrial friction meaning the friction which is generated by the surface of the earth, that friction is negligible above 600 meter or 1 kilometer altitude. This planetary boundary layer. Okay, then we have this 5.6 kilometer altitude, which is called half atmosphere. This is called half atmosphere. Half atmosphere because 50% of the gaseous mass is below 5.6 kilometers altitude. Most of the gases are, rather 50% of the gases are below this line. Oh, all right. Then you have this is your 32 kilometers altitude. This is your TBL or terrestrial boundary layer. Terrestrial boundary layer, लिखो, above which the Coriolis effect due to Earth's rotation, the Coriolis effect due to Earth's rotation becomes negligible. So this is your terrestrial boundary layer. Coriolis effect is 0, and I must tell you that this is called one atmosphere. Why? Because 99% of the gaseous mass is below 32 kilometers. Meaning most of the atmospheric mass is below 32 kilometers. Then you have this 90 kilometers line. This is called friction layer. Why it is called friction layer? Because all the meteors, M-E-T-E-O, meteors catch fire or are burned out along this layer. This is called friction layer. This is at 90 kilometers. Then you have the outermost layer, that is 3200 kilometers. This is your Earth's magnetic boundary. This is Earth's magnetic boundary, 3200 kilometers, because the Earth's magnetic flux will repel the magnetic waves coming from the sun. Keep writing. 3200 kilometers will be called magnetic boundary, because here the Earth's magnetism repels the magnetic waves coming from the sun. planetary boundary layer, terrestrial boundary layer. They are very important. Half atmosphere, 1 atmosphere, frictional layer, magnetic boundary. So please learn all this, and then and there is one here which is called, there is 620 kilometers. This is called thermal layer. 620 kilometers पे thermal layer है, because gases are ionized. Gases are ionized here. Between 90 to 620, the gases are ionized. This is called exosphere also. This is called ionosphere, something like that. Exosphere, ionosphere. बना लिया? Just a minute. Magnetic boundary done. Now coming to the another discussion point. Based on the lapse rate, if this is the sea level, wait, रुक जाओ, it has to be drawn. There is 18 kilometers, there is 8 kilometers, 6 and 16. There is tropopause, and this is your troposphere. Tropopause and troposphere. Then second layer will be 50 kilometers. This is a stratosphere. Draw this diagram also. This is a stratosphere. Then you have 88 kilometers. Mesosphere and mesospouse. This is your 90 kilometers. Mesosphere, mesopause. Then this 0 to 90 will be called homosphere. And then this is called heterosphere. This is called heterosphere. Now 90 to 620 and then 3200. So the upper one is called exosphere and this is called ionosphere. Now within ionosphere, and these two collectively will be called thermosphere. An ionosphere will have several layers like E layer, D भी होता है, D layer, E, sporadic E, E1, E2. There is no need for such. F, G, such layers are there. Now this E is important because this is called canally heaviside and it has heavy side. It has significant role in the communication services. So E is canally heaviside and F is called Appleton. This is the Appleton layer. So E and F are important. E will be roughly till 106 and F ko kuch. These heights are not really fixed. Roughly 420. E is 106, 90 to 106. That's E layer. Using different color. This layer and this E layer. This is very important. These two layers are very important. इस diagram को बनाओ. Create this diagram. I will read out for you. Troposphere, tropopause. Stratosphere, there is a stratopause as well, but leave that. Mesosphere, mesopause. If you have drawn the diagram, please write yes. Tropopause, troposphere, stratosphere, mesosphere, mesopause, then ionosphere. In ionosphere, E layer is called Kennelly Heaviside, HEAVY. मैंने I लिख दिया है, प्लीज करेक्ट कर लो. Kennelly Heaviside, HEAVY. Then you have Appleton layer, around 420 kilometers. Exosphere, ionosphere, mesosphere. Please repeat E layer. स्वाति का डिमांड है. E layer में क्या लिखा? E is called Kennelly Heaviside layer. If you read D.S. Lal or any book, you will find there are layers like E, sporadic E, E1, E2, but there is no need for it. As geographers, we are concerned with Kennelly Heaviside and and Appleton layer. Now please write troposphere. Troposphere. Right, tropos meaning turbulence. Tropos meaning turbulence. And since this layer has vertical and horizontal mixing of air, since this layer has vertical and horizontal mixing of layer, or convections and advections, all the weather phenomena and weather turbulences are located below the tropopause. Below the tropopause. Troposphere is called troposphere because of the turbulence, because of the mixing of the air vertically as well as horizontally. Now right, this layer has density stratification. Let's go into the science. This layer has density stratification. And in the vertical column, generally the temperature decrease with altitude temperature decrease with altitude, which is called the normal lapse rate or the environmental lapse rate, which is called the normal lapse rate or the environmental lapse rate. Normal lapse rate or the environmental lapse rate. Right, which is 1 degree centigrade for 165 meters of height. 1 degree centigrade per 165 meters of height, or 6.4 degrees centigrade per kilometer. 6.4 degrees centigrades per kilometer. .4 degrees centigrades per kilometer. This is called normal lapse rate. Next paragraph. Right, lapse rate refers to मुकेश इंसान बिल्कुल है, आरपीएससी लेक्चरशिप लिखो. Lapse rate refers to the change in temperature with altitude. Change in temperature with altitude. Lapse rate refers to the change in temperature with altitude. And now please write types of lapse rate. थोड़ा डिटेल कर ही देते हैं. So we have lapse rate. What is lapse rate? Change in temperature with altitude. So if here you have temperature and temperature यहाँ होगा, this temperature, and this is your altitude. Then if this is 20 degrees centigrade and this is 0 degrees centigrade, so this curve line will be showing this is the lapse rate, or this is the normal lapse rate. This line is showing the lapse rate and this will show the normal lapse rate. or you can show in this fashion also. This is the temperature. This is where you have altitude. And if you take this diagonal, this will be this line is showing the lapse rate. Whether temperature increases or decreases, whatever. But theoretically, this is called Lorentz curve. Temperature or lapse rate on Lorentz curve. Okay. Now, types of lapse rate. So, lapse rate will be divided into what all? Positive lapse rate and negative lapse rate. Negative lapse rate. What is positive lapse rate? Please write. Positive lapse rate. When the temperature falls with altitude. When the temperature is reducing with altitude, we call it what? Positive lapse rate, because reduction in temperature with height is indicative of normal weather condition. Is indicative of normal weather condition. लिखो, with altitude, the density of the air is reduced. The density of the air is reduced and the density of the air is reduced and the transfer of energy in the vertical column, within troposphere also diminishes with altitude, with greater height. Another reason is the terrestrial radiation, long wave terrestrial radiation, which is responsible for the heating of tropospheric layers. Heating of the tropospheric layers. Heating of the tropospheric layer is from below. Likho, not from the direct insolation. Not from the direct insolation. Your troposphere is not heated by the direct sun rays. It is rather heated from below by the terrestrial radiation. the radiation which is coming back after being absorbed by the earth. लिखो one more point. लिखो another mechanism of energy transfer is the latent heat of vaporization. Most of the latent heat is released. Within 2 to 6 kilometers of the troposphere and not above it. Which means the heat energy cannot be transferred by convective mechanisms above 6 kilometers. Hence, the upper tropospheric layers are extremely cold, with freezing temperatures. Now, there are three factors which are generally quoted for the lapse rate which is found within the troposphere. In troposphere, as you go up, take the example of Himalayas. If you go to the peaks of Himalayas, there are freezing conditions. Why it is so? There are three reasons for it. A, the density of air is much lower in the upper strata. So when the density is less, the transfer of energy will be less. So upper layers have less heat energy. Second, the heating of the troposphere is not from the direct sun rays, rather it is from the terrestrial radiation. So it is being heated from below. And third, even through evaporation mechanism, the energy can be transferred only up to 6 kilometers, and then it's freezing cold. So there, in general, there shall be reduction in the temperature with altitude, and that is what is called positive lapse rate. Why it is called positive lapse rate? Because the atmosphere will be positive. There will be no upheavals, no turbulence. Atmospheric conditions will be normal. Weather will be normal, stable. Atmospheric stability will prevail. Nothing much is happening. Okay? Cool, calm weather, sunshine. So that's your positive lapse rate. Now coming to negative lapse rate, it will be exactly opposite the positive lapse rate. So what is negative lapse rate? Please write. Negative lapse rate, लिखो नेगेटिव लैप्स रेट में तो लिखो negative lapse rate refers to a unique atmospheric या tropospheric condition या atmospheric condition, you can write atmospheric condition, where temperatures begin to increase with altitude. Temperatures begin to increase with altitude. Which means the cold air is underneath and the warm air is overlying it. The cold air is underneath and the warm air is overlying it. Ligo. It is in a spatial condition, spatial, temporary, striking, unique. So it's a spatial condition, spatial but temporary condition within the troposphere. While in the upper atmosphere, such conditions can be permanent. Such conditions can be permanent. Right? If temperatures are increasing with altitude, it heralds the existence of heat energy in the upper layers, either in the form of latent heat of vaporization, or ionized gases, or higher absorption of the sun rays. Because if temperature is increasing with height, the phenomena is also called inversion of temperature. The phenomena is also called inversion of temperature. The phenomena is also called inversion of temperature. So another topic can be discussed here, inversion of temperature, types of inversion and associated weather. But no, I will have to stop because our topic today is atmospheric structure, not inversion of temperature. But inversion of temperature has been introduced to you. So what is inversion of temperature? With altitude, if the temperatures are increasing, and that is what is also called the negative lapse rate. when you have warm air lying above the cold air. That is inversion of temperature. That is negative lapse rate. Now, negative lapse rate, as you have written, can be caused by three factors. A, latent heat of energy, latent heat of the vaporization. So, if water vapor is more present, latent heat could be there. Second, I said absorption of the rate of absorption of the sun rays or insolation. So, the example could be ozone. Ozone absorbs the ultraviolet rays. So, the ozone layer can be warmer than the lower layer. And third, which I quoted, was what? The ionization of the gases. So, if the gases are ionized either by UV rays or by alpha, beta, gamma rays in the upper layer, even that layer could be warmer than the low-lying layer. So, inversion of temperature can be found maybe at three places. Okay. Now, write what is tropopause. Tropopause. No, wait. पहले little more on troposphere. लिखो troposphere is 16 kilometers along equator. Troposphere is 16 kilometers along equator and 6 kilometers along the pole. Look, the troposphere is 16 kilometers, only 16 kilometers along equator. This is your equator. And this is your pole. Likho. Thus, tropopause is a slanting line. Tropopause is a slanting line. Tropopause is a slanting line. Now write the reason why it is so. Because since along equator, insolation is maximum, heating, convection, air currents, are maximum. Air currents are profound, maximum, highly intensified. Hence, the volumetric increase in the gases, are responsible for the greater height of troposphere along equator, greater height of troposphere along equator. Why along equator the troposphere has 16 kilometers altitude, while along the pole they have only 6 kilometers? Why it is 10 kilometers more higher? The reason is the volumetric rise, the rise in the volume because of heating. So when you have heating, the molecules will expand, the weight remaining the same. Even if we let's consider that here the weight of the gases is x, and here also the weight of the gases will be x. So the mass of the gases taken at equator and mass at pole shall be equal. But since heating is more in this region, so it will be fluffy. and this part, the air will be more condensed because of the lower temperature. The condensed air will have greater thickness, and here you have larger volume of the air. This is how, but I tell you something, that the weight of the troposphere will be equal allwhere at any point over the sea level. The mass of the gases will be equal allwhere. The weight of the troposphere will be equal allwhere. It is something like 1 kg of iron at pole and 1 kg of cotton at equator. So cotton will be fluffy and more voluminous. This is the reason why troposphere is achieving greater altitude near equator. I hope understood. Likho. While, next point, while poles have cold conditions, lack of insolation, lack of heating, lack of insulation, lack of heating, hence the cold and condensed air is thick and altitude is low. Altitude is low. There is one more reason for it, which is cited by some of the astrophysicists. So likho, that reason also can be quoted. Right, since the Earth's centrifugal forces, outward forces, Earth is rotating, so it will have centrifugal and centripetal forces. So since Earth's centrifugal forces are maximum at equator, and centripetal forces are maximum at poles, there is a difference in the altitude of troposphere. Now, right, it must be remembered that 90% of the air, 90% of the atmospheric mass, 90% of the atmospheric mass is found below 18 kilometers of altitude. 18 kilometers of altitude. Thus, this sphere or troposphere accounts for most of the atmospheric weight. Most of the atmospheric weight. Most of the atmospheric weight. All right. Tropopause is also called atmospheric lid. Atmospheric lid. Every weather phenomena, weather cyclone, बिल्कुल मिलेंगे इन मुकेश जी। Because every weather phenomena whiz, cyclone or precipitation or air mass or jet streams, air mass, jet stream, cyclone, precipitation, whatever, are found below the tropopause, are found below the tropopause. Are found below the tropopause. So it is called atmospheric lid. Now very important, likho, tropopause have stable thermal conditions. Stable thermal conditions. And the temperature is constant. But above the tropopause, the temperature begin to rise. The temperature begin to rise in the ozonosphere. In the ozonosphere. Thus, above tropopause, inversion of temperature is found. Inversion of temperature is found. Therefore, cloud formations are limited. Cloud formations are limited below the tropopause. Clouds can never be formed above tropopause because temperature is rising. So if temperature is rising, there cannot be cooling and condensation. So cooling and condensation and cloud formation will be limited below the tropopause. And this is how tropopause is called atmospheric lid. It's like a cover, it's like a dhakkan. It covers. And below the tropospheric lid, you have all the cyclones and air mass here. Nothing is happening above tropopause. No weather conditions, no weather phenomena above tropopause. ट्रोपोस्फेयर हो गया। कितना लोग समझा? मुझे लिखो, रिस्पॉन्ड, रीड नोट्स। दिनेश Got it, sir. Arjunarya, Suraj Rai, Briz Kumar, Mukesh, Dinesh Razwar, Nikhil Kumar Pandey. Understood, sir. If not understood, then watch the video at least once. Anuj Mishra, good evening. Geography and You magazine is not available in market. All the good magazines are dying because of this internet and Shikha Yadav, understood. When I explain something, then I am very curious about your learning, because in offline class I can talk directly, but here I have to sit over computer, see your comments. Chalo, okay. Now coming to a stratosphere. So please write a stratosphere. A stratosphere. Likho a stratosphere. A stratosphere's translation is Samtap Mandal, which is wrong. It's so misleading. Samtap Mandal. A stratosphere doesn't have homogeneous temperature. No, it's wrong. So please write, a stratosphere has different stratified zones of ozone gas, different stratified layers of ozone gas, where the lapse rates are homogeneous. Where the lapse rates are homogeneous. This is your 18. This is your 50. Now this is your stratosphere. यही है तुम्हारा stratosphere. Now in a stratosphere there are many layers. There are several layers like this, and in each of the layer the ozone is spreading allwhere. This is how the ozone is spreading in a stratosphere. Now there are different layers, as I told you, and in each of the layer the lapse rate, meaning the temperature change with altitude, the lapse rates are homogeneous. The lapse rates are homogeneous within each of these layers. 1, 2, 3, 4, 5. If there are 6 layers, in each of the layer the density of air. Also right, even the density of air is homogeneous, as well as the lapse rate are homogeneous. That is what has given this sphere the name a stratosphere. A stratosphere doesn't have homogeneous temperature. It has homogeneous lapse rate in each of the layers, and each of the layers also will have more or less homogeneous density. Okay, I hope it is clear to you. Now write, लिखो, within a stratosphere between 32 kilometers to 16 kilometers, 32 to 16 kilometers, ozone has maximum concentration. Ozone has maximum concentration. Thus, it is called ozonosphere. So, what is ozonosphere? It is a layer within the stratosphere. It is not synonymous with a stratosphere. So, this layer between 32 and 16 kilometers is called ozonosphere. It simply means that some part of the tropopause is also part of ozonosphere. So ozonosphere is what? Tropopause, some part of tropopause near equator. So equatorial tropopause plus half a stratosphere. This is what is ozonosphere. Ozonosphere must not be miscued as synonymous with a stratosphere. I hope you are amply clear. All right. Ozonosphere is also called Chapman layer. There is something more interesting. Amit Sharma will appreciate. He always appreciates whenever he learns anything new. So it is also called Chapman layer because this layer has Chapman cycle. This layer has Chapman cycle. This layer has Chapman cycle, which deals with the creation and destruction of the ozone. Which deals with the creation and destruction of ozone. What is Chapman cycle? The creation and destruction of ozone. Right. Along equator, the UV rays, ultraviolet rays are regular, permanent, vertical, most intense. Therefore, maximum activity, most active. Therefore, most active. So UV rays are near vertical here. These are your UV rays. But UV rays will be slanting and weak rays, same UV rays. So UV rays are slanting and weak towards the pole. लिखो इसको भी. While UV rays are weak and slanting towards the pole. And during the winters, they become absent. You must have heard of 6 months night and 6 months day over the pole. So during the winter, when the poles are having 6 months night, meaning sun rays are not able to reach there. So UV rays become absent for 6 months along pole. Continue to write. Right? These UV rays are responsible for the formation of the formation of ozone. The formation of ozone by combining nascent oxygen O with molecular oxygen O2. Thus, O2 plus O is equal to O3, and that's ozone. Now write this ozone, this O3 is transported towards the pole by the stratospheric westerlies. I tell you something, that within a stratosphere, above the tropopause, you have westerly winds. These westerlies are not jet streams. These westerlies are found above the tropopause and within the stratosphere or lower stratosphere. How these westerlies are created, we will talk about it, but not now. Now, currently we are talking about the Chapman cycle. And in Chapman cycle, I said the UV rays are most intense along the equator. So they by charging, by ionizing the nascent oxygen, they produce O3 by combining O with O2. So that becomes O3 ozone. So ozone is actually being created above the equator, and from there it will be transported by the westerlies, the stratospheric westerlies, towards the pole. So here you have the O3. Now understand, here the O3, the chemical bond will become loose because the UV rays are not available. So this, as the ionization is decreasing here, the conditions are extremely cold, UV rays are not available. So again the O will be liberated from O2, and that is what leads to the depletion of ozone. So there is a natural depletion of ozone along the polar areas. We can talk about ozone hole also. That's a relevant topic. But this is a natural depletion of ozone along the pole. So please write, along the pole, the stratospheric westerlies are transporting ozone towards pole, where due to the winter nights and meager amount of UV rays, absence of UV rays, the ozone is depleted. The ozone will be depleted, and the atomic oxygen is liberated from O3. O is liberated from O2, which is known as ozone depletion. Thus, ozone holes above the pole, are natural, are natural. But due to human activities, this natural process has been accelerated. This natural process has been accelerated. And this natural process has been accelerated, and the ozone hole size has increased. The ozone hole size has increased, or the thinning of ozone layer above the pole or the thinning of ozone above the pole have intensified, which is called ozone layer depletion. This is your Chapman cycle. High UV rays, low UV rays. This is your Chapman cycle. Now write ozone layer depletion. Ozone layer depletion according to the recent researches, have been caused by A, the existence of stratospheric clouds, formed by nitrogenous and sulfuric gases, which act as umbrella and does not permit the UV rays to reach the lower layers. Say if this is the pole, this is the tropopause, Then you have, these are the clouds. So the UV rays will be absorbed, either absorbed or reflected back. So here, just below the clouds, you have thinning of ozone. Here the ozone layer is thinned out. This is your ozone layer. This is the ozone layer. And here you have thinning of ozone. This is the thinning, this is the thinned out ozone. Here the density is more. But just below the clouds, you have thinning of ozone. Likho, these gases either have been contributed by pollution. These gases or these clouds either have been formed by pollution or by volcanic eruption. Volcanic eruption during Precambrian, during 3 billion years, 2 to 3 billion years. Or Precambrian. Diagram banao. This is another cause behind ozone layer depletion or thinning of the ozone. Okay. Now second cause is industrial pollution in Europe, USA, mainly Europe, during the Industrial Revolution, that is 1779 to 1980 मान लो. So industrial pollution in Europe. लिखो, these pollutants reached mainly the CFC, HFCs. These pollutants meaning, लिखो, these pollutants or HFCs, CFCs, they are called ozone eating gas. So these gases, HFCs, CFCs were added in the atmosphere and they were transported by the stratospheric westerlies towards the pole. So these gases were transported towards the pole by the stratospheric westerlies and they are responsible for the ozone layer depletion or the thinning of the ozone. So we have three theories on ozone layer depletion. A, the natural theory. B, the cloud, nitrogenous and the sulfuric gases have condensed to form certain clouds. And then third is the HFCs and CFCs. So must learn all this. हम लोगों ने क्या कर लिया? हम लोगों ने वी हैव डन troposphere and a stratosphere. Okay, now we have 3 more layers to do, which I will be doing it in my next class. Not today. I am feeling not so good, not so energetic. I'm sorry, but that is what you had for today. Leaving you half an hour before, almost 20 minutes before. Anyway, I wouldn't have been able to complete the topic. So, thank you. Bye. Take